Welcome to Visual Learning. Subscribe to our channel for technology videos and learning. You can also follow us on Facebook, Twitter, or visit our website at visuallearning.com. If you wish to write to us by email, you can always write at info.visuallearning@gmail.com. You can find my profile in LinkedIn at in/Vijayendra Lakshman Rao. Hello everybody and welcome back to the Big Data Learning series. Today we're going to learn about MapReduce. So in this video today, we will be covering a quick recap on Big Data and Hadoop 2.0, which we discussed in our previous videos, and what is the distributed processing, and an example of distributed processing, as well as let's learn about MapReduce, which is the main agenda of today, and what is the framework of MapReduce, and what are the different stages of MapReduce. Let's learn that with an example. We're going to follow a same example across the video today so that you can relate them easily. And finally, summary of what we covered so far. In this video, we are not covered any programming or coding sessions. So there will be a follow-up video which will come up after this. So please look for that. Let's have a quick recap. So in our previous video, we learned what is big data and how the 5 V's, which actually makes any data qualify as a big data. So volume, velocity, variety, veracity, as well as value. We also learned in one of our videos about Hadoop and HDFS architecture. So in that video, we covered some of the components of Hadoop. We learned a little bit more details about HDFS. We didn't cover any other things. So today, in this video, we're covering MapReduce here, and future videos we're going to cover the many components. So just a quick recap: we had HDFS, we had MapReduce, we have 3 other tools like Hive, Mahout, and Pig. They basically run on MapReduce. And we have a HBase and NoSQL database, and we have ingestion tools like Scoop and Flume, and we have Ambari, which is actually do the monitoring, and of course we have workflow and coordinators like Zookeeper and Uzi. More details on them, it's going to come up in future. However, the introduction on Hadoop as well as big data is available in my YouTube. You can go back and have a quick look. What is distributed processing? Back in days, there was still a lot of scenarios where we have a huge amount of data input coming in, and it used to take days and weeks together for us to process them, and a lot of people has actually used the distributed processing strategy. So let's understand a typical election polling and counting process. There will be a voting booths across different counties or different states, different districts for that matter. In India, we just finished 7 phases of elections. We'll be closing that very soon, and we're going to get a lot of votes across India. We are the largest democracy in the world, and think about somebody has to count those votes manually. So that was the process which was followed from almost 50 to 60 years so far. It does exist, and there was a process in place to solve this problem. Usually what used to happen is that for every voting booth is distributed across different regions or different district or different zones, and these voting booths were sent out as a separate set of bunch of pieces, and those pieces are actually individually can be counted, because we don't have to have a 900 million votes sitting at one place, and even if you consider 50% of it is around 450 million votes, and if one person is putting all of them together in a room and start counting it, this is a never-ending story. So what they used to do is basically they split across, east region, south region, north region, and then there is a bunch of some more splits is going to happen where we're going to talk about a specific district, specific county, or a specific constituency. That's basically a split of data. So if you look at, I'm mapping the same thing across how usually we deal with big data. And each of these votes are actually counted manually by a team or a single person, which is actually going to give us a set of outcome of the specific region. And this will be done in parallel by multiple counting, the team which is sit across the regions in India. And what they do is each of them actually produce their own outcomes. For example, they'll say, hey, look, in this region, there was X number of candidates, and in this X number of candidates, here is the counts, and here is an outcome of that specific region. And then what usually happen is that each of these people, what they generate, those can be aggregated together, and that's exactly how it used to happen. Because before we used to have ballot papers, and people have to literally count the physical loads. If you consider the same thought process, and similar work is done in MapReduce as well. So keep these thoughts in mind. We'll quickly touch base on the same example in the MapReduce thought process. What is a MapReduce? So MapReduce, as per wiki definition, says MapReduce is a programming model, and it associated with the implementation of process and generation of big data sets, like in parallel and distributed algorithms on cluster. More complicated to understand if the English, but if you overall look at it, it's actually a programming model or a framework which actually can help you to process large amount of data in parallel, and by applying a specific algorithm in a huge cluster where one or more distributed systems are in there. So in my previous video, I've actually explained how the problems are solved through the distributed processing by sending the code to the machines rather than getting the data into the centralized machine. So similar process will work in MapReduce. Let's look at the framework by understanding with the same example what we talked about the election polling. There's a bunch of symbols. That's what we use in India for identifying a party. Let's say I have a huge set of ballot papers, or in today's world we have EVMs, or so-called digital machines. So they're actually going to record a different set of counts for every symbol. And let's say if I put all of them together and I'm going to have count by number of symbols, that's my input data, and I'm going to split them into multiple pieces, where based on a region or based on a constituency or by whatever reason, right? So that's actually called as an input split. There is a definition which we can provide for MapReduce and say, hey, look, here is my input data. This is how you split it. Split every line as a new record and consider it as a one record to process it. And if you specify such definitions, what happens is the input data will be split across. Let's say if I have 100 mappers configured, I'm going to split them into 100 pieces, and each mapper will take one piece, and within the split or a piece, it'll have a set of records and it processes one by one. So, and once the split is in place, so it does a counting process. So in this case, all we are telling MapReduce is don't write a complex logic. All you'll do is whenever you find a symbol, just record it as one. I have found one symbol. That's how the count is going to start. So if you look at it, so it's actually counting every single symbol, and next to that is a one count. And similarly on the other piece as well, same kind of work is going to happen on the other side. It's actually a map task. The primary thing we need to understand here is that map task is a common task that can be executed across different data splits. It cannot be a different programs. It has to be a common program across all the splits that can be applicable. So once we have this split, so it doesn't make any sense because I had to club them together and make them as a large data set. That's what is going to happen actually. So basically now there is a sorting shuffling process happens where um, output of all the mappers are taken out, and that will be aggregated and put together in a one section called as shuffling and aggregation. The reducer is going to work on in each of these splits. Basically, if you look at the flower, and this piece is considered as one specific reducer input, and that will calculate there are 24 flowers, there are like 17 horses, there are 15 webs, and that's the output it's going to get. So one thing you have to understand is in the MapReduce framework, the outcome of sort and shuffle are based on a specific key and a value. The key here is a symbol and value is a count, and all the specific keys always go to one reducer. It doesn't get split. For example, if 5 flowers goes to one reducer and another 5 flowers go to another reducer, we can never get an output. So the sort, shuffle, and aggregate job itself is to make sure that all of them come together so that the aggregation, the actual counts will happen easily. Moving on, same stages. I'm trying to explain it with a different example. Let's understand with the word count here. Word count is a very simple example, and if you look at it here, so I'm trying to count number of characters what we have in this word, right? So this is ABR, CCR, and ACB, and the input data gets split into each. In this case, the split records will be by line, so it got split into 3 records, and each mapper will actually start counting it. And then in the shuffle and aggregate, they actually start putting all of them together, one each, across all. So the difference will be, I'll talk about the sorting, shuffling, and there's a C is equal to 2. I'll explain in a minute. And then from the sorting, shuffling, all reducers will get a same key, and the reducers will actually combine the key values and give the count. One thing you have to observe here is the C has become 2. This step is called as a combiner step. So there is a concept called as a combiner where it works like a reducer, but it does the aggregation at a mapper level. That's going to improve the performance for you because you don't have to count many records in the reducers. So there are many benefits. Again, choosing a combiner where, when, and how is something which is a judgment of design, or it's going to come up as a thought if you start doing more and more programming. Stages of MapReduce. We saw so far how the stages look like, but let's have a quick look at how internally it works, right? So all the input files are split into multiple pieces, and each input split has a something called as a record reader. Each record represents that a map task takes one record at a time and process them, and in that we always can define what is my key and what is my value. So when a map task picks up that specific keys, value can be blank as well, just keys will load in the beginning and then we can identify the value, and each map task takes a key as key value as an input pair and also generates a key value pair. So in our case, the input was just a symbol from the input split, and mapper task produced 2 key value pair output, which is a symbol and the count, which is the flower and 1 and flower and 1, like horse and 1. That's output. When the mapper tasks are generate a key value pair, usually we persist the intermediate results in the HDFS, or we can directly pass on to the next stage, which is a sort and shuffle and aggregate by keys. So before the reducers are called, if you see the key 1, it's going to continue to stay, and the intermediate value is going to come. In our case, it was just a symbol and the 1. That's the intermediate value, and the reducer task will run on that and aggregate all of them and generate the final value. So that's how key value pairs are shared across the different stages of MapReduce. In the future video, I'm going to make one sample MapReduce program. It's a Java program, and I think we'll be able to relate it much better. I think let's take the same example and try to depict that. So far we understood it's a programming model of big data, and data exchange is always in key value pair within the framework, and intermediate storage can be HDFS, will be HDFS actually, and map task manage each record and apply the same logic across each record, and the reducer task runs on aggregated data and provides the results on a specific key. And I'm mostly coded in Java language, and if you're not comfortable with any programming languages, as I discussed before, we do have other tools like Hive, Pig, that are comfortable with SQL based framework. Another one is a script based framework, and which internally converts the back into the MapReduce and execute them. That's all for today. Thank you for spending time with us, and happy learning.